We'll get started here about 30 seconds, let people come in. All right, good morning, everyone. Hope you had a good weekend.
Morning.
Any questions over what we did last time? We did not finish 1.4. You were only supposed to do a certain amount of the homework. Any questions over any of that? We'll finish off 1.4 today, and then we'll get into 3.1. Hopefully finish 3.1. I was looking at it, and I'm not sure we'll have enough time, but let's just see how things go. Let's see, in terms of exams, let's see, when is our first exam? We've still got time, February 21st. So yeah, 3 weeks. Wait, hold on. That's, yeah, right about 3 weeks from today. So there'll be a lot of information on that test. But we still have a ways to go. So, all right. Let's get started then. Last time what we were doing was studying how to solve equations, specifically radical equations. And we had a set of steps, isolate the radicals, isolate the radical and then raise both sides to a certain power and all that stuff. So now what we're going to do is switch gears into a different type of equation we need to be able to solve. And that's what we call quadratic form. Okay, an equation that's of quadratic form. And we already know how to solve quadratic equations. We can either factor or use a quadratic formula. That's what we ended class with last time. So let's take a look at our first equation that is of quadratic form. And I have a set of steps here. So the method here, first you're going to take a look at the equation and you're going to make it look like this. So what I'm saying here is that we want to have some number A times some stuff. I'm just calling it a green box. And that green box needs to be squared plus some number B. And then again, we should see the green box, something, whatever it is. And then plus some number C equals 0. So we're basically going to look at an equation and say, oh, this looks a lot like a quadratic. Even though it's not a quadratic, it's going to kind of look like one. And that's where we get this thing, this terminology of quadratic in form. So it's not exactly quadratic, but if we look at it just right, it'll look like a quadratic. Then we will make a substitution where we replace that green box with U. Once we replace that green box with U, then we will have a quadratic equation in the variable U. And then we'll just either factor or we'll use a quadratic formula to solve that. Once we solve that, we'll replace U with whatever the green box was, and then we'll solve that equation. So those are the steps. It's, like anything else, it's better if we just kind of work through an example first and then kind of see how these steps will come into play. So here's our first example. Oops. Hold on. Here we go. So here's our first example. I'm gonna put these steps here to the side so we can refer to them. I'm gonna make them real small. Hopefully you can read that. Okay, so those are our steps. And so we're looking at this equation. We first noticed that it's an equation, right? We have an equal sign in here, and we're gonna try and solve this equation. So we look at it, and this is where we have to kind of be willing to kind of like, change our perspective, look at it from a different, point of view. When I look at this, I kind of see that I've got x plus 2, those are the exact same things, right? So that's kind of like the green box. In front of the x squared plus 2 out here, there's like a 1. Then I have plus 11. Then I have minus 12. So this looks a lot like a quadratic if we're willing to kind of squint our eyes and and see that this this x plus 2 is kind of like a variable, right? And so that's the first step, is to recognize that this kind of looks like a quadratic. So the second step is to make a substitution, which would be to let u be equal to whatever that green box thing was, which was x plus 2 in this problem. And if I do that, then I can rewrite the equation. And let's see, who did we not call on last time? How about Michael? Is Michael here? Michael G? Don't see Michael G. Where's my participants? Oh, there you go. No Michael G. Okay, how about Lizette? Are you there?
Yes.
Okay, Lizette, are you understanding what's going on here?
Kinda, yes.
Okay. Try and rewrite this equation, but replace the x plus 2 with u and tell me what the new equation would look like. So everywhere you see x plus 2, just make it a u.
So like u squared plus 11u
Mm-hmm.
minus 12, then just equal to 0.
There you go. Perfect. Okay, good. So that's what we're doing here. We're trying to rewrite this. Now we have just a quadratic. This is just a quadratic equation. And so we have one of two options here. We can either factor this if it factors, or if it doesn't factor, we can use a quadratic formula. So I believe this one does factor. Does somebody want to volunteer and tell me how this factors? Or do I need to call on somebody? It does factor.
Is it 1 in 12? Oh wait, yeah. Is it
Okay.
like negative 1, 12?
Okay, yeah, so this is what we're doing, this thing over here. -1, +12 will work, yes. So that would become, if we do what we did in the past, this would be u minus 1, u plus 12, and then you take the number in front, which is a 1, and you put it in front of 1 and underneath the other. But I told you that if it's a 1, nothing changes, right? So this is just the result, equal 0. We need equal 0 here. Sorry, I didn't see who said that. I want to mark you down. Who responded?
Me,
Was that
Lizette.
Lizette again? Okay, good.
Yeah.
All right. Okay, so good. Now, once we have it factored, we can just set each factor equal to 0. So I'm still in step 3. I'm solving this. So I'm going to set u minus 1 equal to 0. I'm going to set separate equation u plus 12 equal to 0. And then just move the numbers to the other side, which really just changes the signs of the numbers. So those are our two solutions. And now we go to step 4. Okay, because right now we're not done. We're not saying the answer is 1 and -12, because remember, we made a substitution, right? We let u be equal to x plus 2. So for step 4, I'm just going to take these equations and replace the u with the substitution we made, x plus 2. And then replace here, x plus 2 equals -12. And now we have two new equations that we're going to solve. So step 5 is to solve those. And those are just little linear equations, right? Those should be easy for us to solve. Just isolate the x. So subtract 2, subtract 2, subtract 2, subtract 2. So we get x is equal to -1, and x is equal to -12 take away 2 is -14. So those should be our two solutions. And I have some good news. We do not have to check our answers because we never like squared both sides of the equation. Right? If you ever square both sides of the equation, you're going to have to check your answers. That's what we did last class. So with this, we don't need to. Okay, any questions? So if you go back to the original equation and kind of look at it again, what we really did here was we replaced this with u and this with u, and then rewrote it as u squared plus 11u minus 12, right? That's what we did. Let's do another one.
I have a question.
Yes.
So what's the significance of the u? Like if we're gonna change it back to x.
Wait, say again. It's hard to hear you.
I'm sorry. My computer is having so many problems right now.
Yeah.
What's the significance of u if we're gonna change it back to the x?
Just to make it easier to work with. That's all. The significance of making the substitution is so that when we make the substitution, what we have here on this line here in blue is something a little bit easier to look at.
Okay. Okay.
And so once we get it there, we say, oh, we just solve that like we do any quadratic. And then once we get our answers, then we switch it back to x. This is a very common technique in math to make a substitution. In fact, in my Cal 2 class today, we're going to be doing this to solve hard problems, like really hard problems. We're going to be making a substitution that's going to, actually the name of the section is called substitution. So it is a very useful technique to make a substitution to make a problem easier. Let's do another one. Maybe you'll see how it kind of helps. Okay, so when you look at this, this is kind of a tricky problem because if you look at it from one perspective, you could say this is a radical equation, right? What we did last class, because you see a square root in there. You could solve this one that using that method, isolate the radical, get it on one side. You could do that here, but I want to see if we can maybe look at this equation and see that it is a quadratic form. Okay, so can we see that it's a quadratic form? Does anybody see what the u would be here to make the substitution? Henry, looks like you got something.
Yeah, wouldn't you replace both the x's with u and then leave the 3 and the 2?
So you want to replace x with u, like replace that with u and that with u? Just the
Yes.
x? Okay, so if we replace just the x with u, right? If I did this, if I'm understanding you correctly, then the new equation would be u plus 2 root u minus 3 equals 0. I think that's what you were saying. Now, does this help us though? Have we made it look now like a quadratic, right? Does it look like ax squared plus bx plus c equals 0? Not really, right?
Yeah.
Yeah, not really. This just looks like the same equation with the u instead of an x, right? That's what it looks like. So that won't work, okay, to just do u equals x. So maybe something else?
Would it be the 2?
Replace the 2 with u? Is that what you're saying?
Yes, sir.
So if we
Or
replace,
the 3. I feel like it's one of those numbers, but I can't like.
I'm
I'm gonna go with the 2.
the 2.
No, I'm gonna go with x squared. Oh
You're gonna
dang, I don't know.
Okay, well, I'll tell you one thing. In math, especially moving on into calculus and pre-cal and all that later on,
Mhm.
you have to be willing to do something, all right? You can't just like look at something and quit, right? So you got to be willing to try something, which is good, right? Even if you're wrong, okay, fine, you start over. Let me, since this is the first time you're seeing this problem, let me do something. And then when I do it, I think you'll see it. Do you all agree that x could be rewritten this way, even though we don't normally do this? Could it be rewritten this way? Square root of x squared. It could, right? If I square a square root, the square root goes away, and that would just be x, wouldn't it? Now, if I do that and then just write the rest of the problem, now do you see what you could let your u be? Henry, do you see it? Sierra?
I see.
Yeah. What would it be? What do we let our u be?
Would it be the x squared? The what's in the parentheses right there?
What's in the parentheses? The square root of x. Yeah, that
Mhm.
let's do that. If u is the square root of x, right, then I'm going to rewrite the problem. Everywhere I see a square root of x, I'm going to replace it with u. Okay, so this becomes u squared plus 2. Now this becomes u, 2u minus 3 equals 0. Does that make sense? It's kind of weird because you have to realize that x is actually the square root of x squared. Like you have to understand that. That's why me showing this to you, if it's the first time you're seeing it, you're like, oh, okay.
Yeah,
now
that was a little weird.
Yeah. So this now becomes u squared plus 2u minus 3. Now this is a quadratic, right? This is now a quadratic. And I'm gonna write something down here because this is like terminology, language. The way you'd write this, or the way you'd say this is a quadratic in U, okay? It's a quadratic in U, meaning that it's a quadratic equation in the variable U. When you write this down, like this is the way you're used to seeing quadratic equations. Let me do this. 3x squared minus 4x plus 1 equals 0. This is a quadratic equation. This is one that you're probably familiar with. You look at it, go, yeah, I've solved those before. This is what would be called a quadratic in X, meaning that the variable here we see is X. This right here, this new equation is a quadratic in U. So we're going to solve it. And this one does factor. It also factors, we could use, I'm not going to show it, but this is u plus 3, u minus 1. Those two factors. So I'm not showing this step anymore, okay? So if you have question marks on this, again, this is something you're gonna need to go back and review. I'm just going right to it. And now I set each factor to 0. Let's solve for u. U is -3, u is 1. Questions up to this point? What do we do now? I've kind of lost track of the steps here. We looked at it, we made a substitution, we solved it, and now we're going to replace u with whatever we had put in there, right? So I'm going to replace u with the square root of x. So I'm going to rewrite this as square root of x equals -3. And this one, square root of x equals 1. That step is actually called the back substitution step. You're basically substituting back what you originally had substituted out. So I'm back substituting the square root of x back in. And now look at those equations. Jose, are you here?
Yes, sir.
So what type of equations are those, Jose?
It will be.
Think about last class.
Could they be linear equations?
Well, if it was just x, yes, but it's the square root, right?
Yes.
So those are radical equations, aren't
Radical. Yes. Yeah.
they? The radical equations. So
My
we had a
notes.
whole procedure for that, Jose, right?
Yeah.
We would
Yeah.
have to isolate the root. So are the roots isolated here? Are they by themselves?
Yeah, I believe so.
Yeah, they are, right?
Yeah,
So we
they
don't
are,
have to
yes.
isolate them.
Yeah.
So now we just need to raise both sides to a power to kind of kill off the root, right?
Yes.
So we should raise both sides to what power? To kill
2.
off the square root. Yeah, 2. So we'll square both sides, right? We'll square both
Yes.
sides. And then on the left equation, we get x equals 9 because we
9.
need to square -3, right? And
Yes.
the other one is x is
X
1,
1.
right? Now, what do you
Yes.
think, Jose? Do you think we have to check our answers?
No.
No? Did
No.
you raise both sides of the equation to a power at any point in time?
No.
What did
Oh,
we
I
square?
mean, yes. Yeah. Yeah.
We did,
The
right?
second part. Yes.
So as
Oh,
soon
so
as you do that, you've got to check.
we
answers.
have to
You
check.
have to
answers.
check answers.
Yeah.
Okay, we have to, unfortunately. All right, everyone
Yes.
clear with that? We're gonna have to check answers here. So when we check our answers, what I mean is you have to go back to the original equation, okay? And I'm running out of room here. I'm gonna take this, here's where I'm going to check, okay? I'm gonna check over here. So let's check x equals 9. Let's see what happens here. If I replace x with 9, let's see if it's true. So we would get 9 plus 2 square root of 9 minus 3. And the question is, does that equal 0? So order of operations, square root of 9 is 3, right? This is 9 plus 2 times 3 minus 3. Does that equal 0? 9 plus 6 minus 3. Does that equal 0? I don't think that equals 0, does it? It does not. Right? This is what, 12, I think, on this side? 12 doesn't equal 0, which means that 9 is not a solution. So we have to go check the other solution, 1. So if I check 1, then I plug in 1. So 1 plus 2 square root of 1 minus 3 equals 0. This is 1 plus 2 minus 3 equals 0. And that's 3 minus 3 equals 0. Yes, that's true. So x equals 1 is a solution. Questions? It's hard to tell from the looks on your faces whether or not this makes sense or not. Just as a kind of recap of what we did here, we had to kind of look at this, and the big thing was to realize that x can be rewritten as the square root of x squared. Then you have the substitution, then you solve the quadratic, then you replace, then you solve whatever's here, you have to solve. If it's a linear equation, you solve it. If it's a square root equation or a radical equation, you solve it. Whatever it is, you have to go solve it. And then you solve it, and then in this case, we had to check our answers. We checked them. We only have one answer that works. Okay.
I have a question.
Yes.
When it comes to the, okay, so the, maybe it's the first part. Yeah, the first part where we had to figure out where to factor or where to plug in U4.
Uh-huh.
The X, yeah, right there.
Yeah.
I don't even know how to ask this question, but I don't know. I think that part's just confusing me a little bit because honestly, I don't know. I think it's just the square root that's messing me up here.
Well, the thing is, I guess the thing that you have to realize here is that maybe now this is more like now you've seen it, okay? Like I've shown this to you now. So now that you've seen this, you should be like, oh, okay. Whenever I see,
I definitely, once you were checking at the bottom and trying to figure out which one is true, I was like, oh, dang, yeah, I remember doing this before.
yeah.
Okay,
So now that
maybe
you've
it's one of
seen
those
this, you want to
differences
kind of be
between-
thinking, hey, maybe if I ever see a square root of x in here, I need to see, like, if I see x, I can rewrite it that way.
All right, okay, gotcha.
You know?
I'll just use this one for reference.
Yeah, I'll make up another one. Here, let me just make one up. This one's going to look different, okay? It's going to be a quadratic type, all right? So let's go with this. How about 2x to the 2/3 minus 5x to the 1/3 plus 2 equals 0. All right, so when you look at that right away, this is not a quadratic equation, right? I mean, all quadratic equations look like this. Ax squared plus bx plus c equals 0, right? That's what a quadratic is. And so we have some variable squared, right? And then some variable by itself, and then no variable, right? That's basically all quadratics look like this. This is not a quadratic because we don't have x to the second power and then x to the first power, right? We don't have that. Agreed?
Yes.
So, but it does look a lot like a quadratic in the sense that it, it's like at least 3 terms, right? It's 3 terms. So, I mean, in that sense, it's similar. So on this one, I'm going to show it to you again. I'm going to show it to you first. And then once I show this to you, now you know to start looking for this. So
Gotcha.
watch, I'm going to do 2, watch what I do here. 2x to the 1/3 squared. That didn't come out right. X to the 1/3 squared. I'm rewriting x to the 2/3 as x to the 1/3 squared, because we have this property of exponents that you have x to a power, you multiply the powers. So I know that I can get 2/3 by multiplying 2 times 1/3. 2 times 1/3 would give me 2/3. So this is just another way I could have written this. And then over here, well, I already have x to the 1/3 here, don't I? And then plus 2 equals 0. So now these two are the same, right? Those two are the same. And so if I replace that with u, I'm going to have a quadratic. Do y'all see that?
Okay, yeah, I do see that
No?
now.
Everyone got that?
You just have to make sure they're in, I guess, quadratic form. And
That's right.
they have to be to the second power. And
And
do
then
they
to the
have to be
first.
like terms?
Pardon me?
For the exponents, do those have to be like terms?
No, this one, so like if you go back to the quadratic, it's always x squared, then x to the first, right? So we need whatever it is squared, and then whatever it is to the first power. That's what we need. And these two things in yellow have to match, right? They have to be
Okay.
exactly the same.
I think I'm tracking.
So I'm going to make my substitution. U is equal to x to the 1/3. Okay. And once I do that, I can rewrite the equation. So let's see, Isabella, are you there? Oh, Isabella, we've talked already, I think, right? Yes, I believe.
Yes, sir, sorry.
Okay. How about Gloria? You there, Gloria? No Gloria, no Gloria? Okay, how about Zane?
I'm here.
Okay, Zane, you understanding?
Pretty much.
Okay, can you tell me what the new equation is, replacing the x to the 1/3 with u? What is our new equation?
Would it be 2u squared
Mhm.
minus 5u and then plus 2?
Yep, that's it. Okay, good. There we go. Now we need to see if we can factor that. If it doesn't factor, you can use the quadratic formula. Okay, either way, we need to get to 2 answers. So I made this one up, but I made it so it would factor. So again, I'm not showing this work because of time. We don't have time for this. I believe I made it where it'll work. Hold on. Let's see, does it work? 2u, u. Oh no, does it not factor? 2, 1 minus minus. I think that works. Let me see. We get 2u squared, we get minus 4u, minus 1u, that's minus 5u, and then plus 2. Yeah, that works. So again, I'm not showing this step. Okay, I'm not showing that step because that's a prerequisite topic for the course, right? So I'm not expecting that you would do that just automatic, but I expect that you could get that. All right. Now we take each of the factors and we set them equal to 0. And we solve these. These are nice little linear equations. So I will move the 1 over here and I will divide by 2. And here I'll just move the 2 over. So we have 2 answers so far. U is 1/2 and U is 2. All right, let's see, Michelle. How's it going, Michelle? You there? You there? I don't see Michelle today. Diego? How's it going, Diego? I've been watching you and you seem like you understand this. Yes?
Yeah.
Okay, so what would I do at this point, Diego?
You would substitute the u for what you originally like wrote as u, right? So you would substitute u for x to the 1/3 power.
Okay, equals the half, right?
Yes.
And then the other one will be the same thing, x to the 1/3
Yes, sir.
equals the 2. Okay, Diego, how would you go about solving that now?
So you would raise both sides of either equation by 3, right?
3, yeah, 3 on this one, 3 on this one. Okay, keep going. What would you get here? The x to the 1/3, raise it to the third, just gives you what?
It would be x is equal to 1/8, right?
1/8, good, 1/8, because you're doing 1/2 times a half times a half, and you just multiply straight across. And then on the other one, you get x equals
So x is equal to 8, right?
8. Yep, okay, good. Now, since you understand this, Diego, I can tell you you do. Do I have to check my answers, Diego?
I'm not sure. I think so, right? Because you raise both sides by an exponent.
Yeah, so I've told you that anytime you raise something to a power of both sides, you should check your answers, right?
Okay.
It turns out that you only have to check it if you raise it to an even power.
Okay.
All right. So here we raised it to an odd power, right? 3 is an odd number. We don't have to check. It's only when you raise it to like the 2nd power or the 4th power or the 6th power. And the reason for that is that when you square a number, it always comes out positive. So you could have a negative in there, and then when you square it, it becomes positive. So it kind of messes the signs up. Anytime you do an odd power, it keeps the sign. So we can trust that these answers will work. Now, if you just want to be super safe, check your answers. Okay, just anytime you raise both sides to anything, check your answers. But I'm going to trust that these are correct, so I'm just going to stay with them. Okay, I hope that that kind of helped illustrate again another quadratic type. I think I want to do one more. Sorry, I'm going to do one more. There's no such thing as doing too much of this because this comes into play later. Not in this class, but later. This sort of algebra. So let's do this one.
Sir, I had a question.
Yes.
When you factored it and you got the 2u minus 1 and the u minus 2,
Yes.
I understand that the -1 and the -2 is going to equal the +2 in the equation, but it's not going to equal the -5. Does that matter, or?
I think it will.
I'm
If you
just looking
distribute,
for-
right, you go here to here, right? That'll give you 2u squared, right?
Mhm.
Then you go here to here, and that'll give you -4u. And then you go here to here, and that'll give you -u. And then here to here will give you +2. So when you put these two together, you get -5u +2, and then 2u squared,
Oh, okay, now I see it.
which is
I
the
didn't see it
original.
at first, but
Yeah, you scared me. I was like, oh crap, did I factor wrong?
yeah, I was trying to figure out like how do we get the -5?
Yeah, so what I would have done, okay, now let's just do it. What I would have done here is I would have taken, if I were going back and doing this, the method that I'm not showing, I would go 2 times 2 is 4. I put the number here, -5. I try to come up with 2 numbers that multiply to be 4 and add up to be -5,
Mhm.
right? So what would they be? -4, -1?
Yeah.
Right, that's it. That's all you can use. So now what you would do, at least what I told you in previous classes, you would put -4 here, -1 here. You would put the variable, which in this case is u, not x, here. And then you take the number that's in front, 2, right? Our number is 2 here in front, and you're going to put it in front of one of the u's and underneath one of the other numbers. Do you remember me saying that? This was like the super shortcut. So I would put the 2 here and then underneath here. That's what I would do. And then it would become u minus 2, 2u minus 1, which is exactly what I have here, just written in a different order. Okay,
Okay,
All
I
right.
got it.
good. Let's do another one. You ready? This one will be interesting. So let's go with t to the -4. Hold on, I'm thinking here. Minus 10 t squared plus 9 equals 0. T to the -2, not t squared, t to the -2. Okay, I'm going to give you a few minutes to see if you can figure out. I'm telling you, this is a quadratic type. You need to figure out what the u needs to be. All right. And I'm going to do a poll. If you figure out what the u is, I want you to answer the poll when you think you've figured out what the u should be. All right. Here comes the poll. Yeah, it's just yes or no. Don't answer until you've found what u is. If you're having trouble finding u, then you might notice that on all of the previous examples we've done, u has always been the thing that's in the middle. Like here, it was x to the 1/3, it was this. The one before that, right? This one right here, the square root of x, that's what u was. Right? Now, it doesn't always work that way, but it's a place to start at least. So I think with that, I'm just gonna work this one out. So I've got nine people telling me, 10 people telling me they've got it. So what is it? What's it gonna be? U is gonna be what?
The t.
T to the -2.
-2.
Yep, t to the -2. Now, what we have to realize is that t to the -4 is actually t to the -2 squared. Again, using those properties of exponents, that if we multiplied -2 times 2, we would get -4, right? So we have to see that. So we have to see that this can be rewritten as t to the -2 squared minus 10, and then again, t to the -2, and then plus 9 equals 0. Now, if I make my substitution, this becomes u squared minus 10u plus 9 equals 0. Any questions on that? I factor. It does factor. And I get two solutions, 9 and 1. Give me just a second here. Sorry. Okay. So now that I've figured out what u is, I need to replace it. So I replace the u here with t to the -2 equals 9 and t to the -2 equals 1. Go with me or not? You understand? Now, at this point, we have several options in terms of how to solve this. The way that I think would be most useful to you is if I remind you what t to the -2 really means. T to the -2 really means 1 over t squared equals 9, and then 1 over t squared equals 1. That's what t to the -2 means, right? If you raise something to a negative power, you can drop it down to the denominator. Now that I'm here, I need to solve for t. What I'm going to do, I'm not going to raise both sides to a power. What I'm going to do is I'm going to clear the fractions by multiplying both sides by t squared. I'm going to do that on both of these. And what happens is on the left, they cancel. You're left with 1. And then over here, you have 9t squared. On the other one, the t squareds cancel, you have 1. And then over here, you get 1 times t squared, which is t squared. Let me focus my attention on the left equation. Let's divide both sides by 9. And once I'm here, now I'm going to solve this by doing what we've done in the past, and that is take the square root on both sides. So when I do that, I have to do plus or minus, and I get t on the right side, and on the left side, the square root of 1/9 is 1/3. So plus or minus 1/3 is t. And then on the other one, I'm going to do the same thing. I'm going to take the square root of both sides, and I get plus or minus, in this case, 1 is t. Just don't forget that if you take the square root on both sides, you have to do plus or minus. So that was a weird problem, right? You've got to see that t to the -2, t to the -2 squared is t to the -4. Then you've got to rewrite it as quadratic, solve it, and then this weird thing where you drop the t down and then cross, like multiply both sides, clear the fractions. So there's quite a bit going on there. Yeah, what do you got?
How did you change it to 1/9? Like whenever at the very, like towards the very last step.
Right here, I took this and I divided both sides by 9 here, so that I could get t squared by itself.
Oh, okay. Okay, just isolating the variable.
Isolated the variable, exactly.
Can we do another question like this?
Say again?
Can we do another question like this?
We can do something else, yeah. Let me see. Let me think of one. Yeah, I'll do one with a negative, another negative exponent. Let's do this. How about x to the -6? Well, I got to make it somehow work a little bit for you. Minus, we'll go, yeah, minus 28 x to the -3 plus 27 equals 0. So I'm going to realize that x to the -6 can be rewritten as x to the -3 squared. Right, that's another way I could write x to the -6. And if I do that, I'll have x to the -3 squared minus 28 x to the negative 3 plus 27 equals 0. I make my substitution. I know I'm working through this quickly. X to the negative 3 is u. So this becomes u squared minus 28u plus 27 equals 0. That factors. And then I can set each one of these equal to u. I realize I worked through that quickly. Are there any questions on that, what I've done so far? Okay. Now I replace u with x to the negative 3. So this becomes x to the negative 3 equals 1. X to the negative 3 equals 27. I can rewrite x to the negative 3 as 1 over x cubed. I'll do it over here also. I will clear the fractions by multiplying both sides by x cubed. And I'll do that on both of them. The x cubes will cancel, I get 1 equals x cubed here. And over here they cancel, I get 1 equals 27x cubed. And then this was the step that Dominic was just asking about. Like, I've got this 1 equals 27x cubed. I'm going to divide both sides by 27 to get the variable x cubed by itself. And then over here, there's really nothing to do because I have 1 equals x cubed. So here I will take the cube root on both sides of the equation. Cube root. Cube root. Now, when you do cube root, do you have to do plus or minus? Because when you do square root, you have to do plus or minus. Lizeth is shaking her head no, right? Cube root, no. Okay, you do not do plus or minus. You just leave it. So we'll just have the cube root of 1, which is 1. And the cube root of x cubed is x. So that's one answer. And then on this one, the cube root of 1 over 27 is 1/3. And then the cube root of x cubed is x. So the cube root of 27, one way to look at this is that's cube root of 1 over cube root of 27. That's really what we're doing here. And the cube root of 1 is 1, and the cube root of 27 is 3. So that's how I got 1/3 done. Okay, I hope that that's enough. You're going to need to do your homework and see how this goes. We need to move on. We still have a little bit more to do in this section. So let me move to the next type of problem we want to be able to do. So we are no longer looking at quadratic form. We've now moved on to just equations that require factoring. And this problem right here is a classic problem. I have my calculus students still have trouble with this sometimes. How to solve this equation. So let me give you 1 minute to just see algebraically how you would maybe go about this. I'm gonna just let you kind of mess with it for a minute. Okay, that's enough time at least to let you think about how to go about it. Anyone want to tell me how they proceeded to solve this?
don't you first move the 4x squared to the left-hand side?
You move the
And then
4x
equal that
squared
to
over.
0?
Okay, so you subtracted 4x squared on both sides
Yes.
and got it to be equal to 0. So everyone, this is what happens. Subtract 4x squared here, subtract 4x squared on this side. Goes away here, you get 0 on this side. You cannot combine these together. They're not like terms. Good, this is fine, I agree. What did you do next?
And then you would factor out, so it would be x squared parentheses x squared minus 4 equals 0.
Good, so that was a GCF, right? You factored a GCF out, greatest common
Yes.
factor. And then did you see what else you could do?
That's all I got to so far.
Yeah, okay. Well, since you've gotten this far, do you recognize x squared minus 4? Is that not a special case of something? We call this
Is it the difference of squares?
that's the difference of squares, right? This right here is a difference of squares. So this can be factored even further to be x plus 2 times x minus 2, sitting next to that x squared. And now that we're here, we can take each of these things, since they're all multiplied together, we can set each one of them equal to 0. So I can set x squared to 0. I can set the other one, the next one, x plus 2 to 0. And the last one, x minus 2 to 0. And then I can solve each of these. So if we look at the first equation, what is the only number that you can square and get 0? There's only one number that works with. What number?
Is it 1?
No, 1 squared is 1.
Or
0, right?
0?
0 itself. 0 squared is 0. So the solution of this one is 0. And then the others, you just move the numbers to the other side. So this becomes x is negative 2 and x is positive 2. And that's it. Those are our 3 solutions, right? We have 3 answers. Now, very good. I want to show you an incorrect way to do it. I hate showing incorrect ways, but this is important. What if a student comes in here and does this? Divides both sides by x squared. Okay. You may have thought, okay, I'll divide both sides by x squared. If you do that, these x squareds will cancel. And then here you have x squared over x, x to the 4th over x squared. That will leave you x squared because you subtract the exponents. 4 minus 2 is 2. And on the right side, you have 4. And then you come through and you take the square root on both sides. And because you did that, you have to do plus or minus. So you'll get x here, and then here you'll get plus or minus. Square root of 4 is 2. So you'll get 2 answers, 2 and negative 2, right? You're missing an answer, right? You're missing an answer. So why are you missing an answer?
Is it because we got rid of the x squared?
You divided both sides by x squared, right? If you divide both sides by x squared, anytime you divide by a variable, you have to promise me that that variable will never be 0, right? This division actually eliminates this right here. Basically, you're making me a promise that x can't be 0. That's the only way you're ever allowed to divide both sides by x squared, is if you promise x can't be 0, because we can't divide by 0. But 0 is a solution. So you've eliminated a solution this way. So the correct, I guess the thing I want you to take away from this is moving ahead into more math. You're always allowed to multiply both sides of an equation by anything and divide by anything except 0. And so if you're multiplying or dividing both sides of an equation by a variable, then you're possibly going to eliminate an answer. So the best way to approach the problem is to do it this way over here, which is instead of trying to divide through by the variable, move everything to one side and then do a GCF. That's the way to go about it. All right. Then you won't lose any answers. All right. So just be careful with that. That's the whole point of that problem, is to show you the difference between the two approaches, and that one of them leads you to something wrong because you're missing an answer. All right, next one. This problem, this is our last problem for the section. This problem is to make sure that you remember how to factor something with 4 terms, right? We have 4 terms here. 1, 2, 3, 4 terms equals 0, right? So we have 4 terms. And to do this, to factor this, we're going to use, I need to make sure you remember how to use this technique called grouping. Grouping. So the way we do grouping is this. At least this is the way I teach it. I always say, look at your first 2 terms. As soon as you, right after the second term, just draw a big slash mark like this. And what you're going to do is basically split these four terms into 2 groups. The first group are these 2 terms. The second group are these 2 terms. And what you do is you focus all of your attention on these first 2 terms, and you try and pull a GCF here, just out of these 2. Do these have a greatest common factor? So we look at them, we say, oh yeah, we can pull x squared out of both of them, right? And then that'll leave us with x minus 1. Okay, so these first 2 terms can be rewritten this way. And now what I'm going to do is I'm going to try and see if I can pull something out of these 2, a GCF, to leave me with an x minus 1 in parentheses again. So the way I like to think about it is this. I need to see if it's possible to have an x minus 1 here, and I need to come up with what I'd have to pull out. What do I have to pull out of this to leave me with an x minus 1? So if I look at it, I'm going to need to pull a -4 out. Because if you pull a -4 out, -4 would distribute back through here and give you back these 2 terms. Once we're here, we notice that these 2 things match. What we do now is we say, if those 2 things match, then what we can do is we can factor it out. We can pull the x minus 1 out. Okay, so we're going to pull this pull the x minus 1 out of the out of the 2 terms, and then what will be left is whatever was in front of the 2 terms. Now that step right there, a lot of students know how to do that step, but a lot of students don't know why they're doing that step. So I want to just kind of remind you of why we're allowed to do this. Just ignore that for a minute. If I wrote this down, x squared m minus 4m equals 0. If you were looking at this and I asked you to pull a GCF, I think everyone here would agree that m can be pulled out, right? They both have m. So I can pull the m out, I pull the m, and I'm left with x squared minus 4. Most students are good with that. They understand that. That's exactly what we just did here. Okay, this is like the m and this is like the m. So what we did is we pulled the m out, and that left us with the x squared minus 4. That's exactly what we just did. All right, so I want you to understand that, because understanding it is better than just doing it and not understanding why you're doing it. All right, so there's where we are. Now I can notice a difference of squares again on the x squared minus 4. And then I can set each of those equal to 0. So x minus 1 equals 0, x plus 2 equals 0, and x minus 2 equals 0. And we'll get 3 answers: 1, -2, and 2. So I'm going to do a quick poll here. I just want to know how many of you remember seeing grouping at some point in time, doing grouping, yes or no? Okay, good. That's a very strong majority. So if you haven't, you're going to need to make sure you go back and review that, get some help with that. All right. Office hours, tutoring, whatever it is. Question for you. Does grouping always work? Like if you have four terms, is grouping always going to work? So like if I make up a problem like this, x cubed minus 3x squared plus 4x minus 5 equals 0. This is four terms. I try grouping here. Is it always going to work for me? Well, let's see. I can pull out of the first two. I can pull an x squared out. I'm left with x minus 3. And then I say, okay, well, if this is going to work, I need an x minus 3 here. And so I need to figure out what goes here. And if you look at this, I need a 4x. The only way to get a 4x is if I put a 4 out here. And that will give me the 4x. But if I distribute the 4 through here, I'll get negative 12, and that's negative 5. So that's not going to work. So grouping does not always work. Okay, not always. So in this class later on, we are actually going to figure out a way to do something like this. All right. Right now we don't have a technique, but we will figure out a way of doing this. All right. We'll get a more powerful technique later. All right. Okay, that is it for the section 1.4. Okay, that's it. We're done. So you can go back. I'm going to reopen the assignment and you can go back and finish that off. Okay. Let me see. You know what? Let me do that now. Take a moment. Take a moment while I'm reopening this. Take a moment to look at this definition of a function. I'm just going to go reopen that for you real quick. And you can take a little break if you want. Okay, I have updated that. That 1.4 has now been moved out to be due by the 1st. So tomorrow at midnight. Tomorrow at midnight it'll be due to finish out the problems. Okay, so we are now going to talk about functions, and I'm going, even though this is not a review topic, I'm going to assume that you have seen functions before. So I'm going to move kind of quick through this, but there are certain things I'm going to need to stress to you, all right, to make sure that you understand. First, the definition of a function. So the idea of a function, this is a visual representation of a function. You basically have some sort of rule or relationship. They call it a relationship. You could call this also some sort of rule that basically takes a number, right? It's going to take a number. Number as an input. It does something to the number and it spits it out as a number. Right? And that number is usually a new number, right? So you think about it like a machine, right? You put something in the machine and it has something that comes out the other side. I like to think about it like a car wash, right? You have this you know, your car goes into the, you know, it's dirty, goes in here, comes out, clean car, right? Well, this right here is the function. It's the actual machine. It does something takes an input and it spits out an output, right? So if we think about a function as being like a car wash, we know that there are certain things you cannot put into a car wash, right? Like certain car washes can't handle like 18-wheelers, or if your truck's too tall, you can't go in there, you know, right? So functions do break down. And so the things that are allowed to go in, right? The cars that are allowed into the car wash would constitute what's called the domain of the function. Okay, the things that are allowed to go into the function. The function can handle it. The car wash can handle it, right? And then you'll get an output. Another important aspect about a function is that to be a function, you can't have this happen. Was there a question? Or someone just told me? No? Okay. So here's something that can't happen, right? You can't send a car into a car wash and then on the other side have two cars come out, right? Man, my cars suck, don't they? All right, there we go. Right? That would be a hell of a machine, right? Especially in 2022, cars are so highly valued, right? You come over the car wash where you take one car in, it spits two cars out, you're definitely in business, right? This doesn't happen. Functions don't do that. Functions take one thing in and send one thing out, right? That's what makes a function. One input, one output. And that's what this means here. It associates with each element X. So with each car that goes in, there's exactly one car that comes out. That's what that statement's saying. One input to one output. That's what makes function a function. So I'm gonna draw you a picture. This is kind of like the common way we look at functions. I'm gonna draw you, like, imagine there are numbers here. This is the domain of the function. And here's the output, which we call the range of the function. And tell me whether or not this is allowed. Let's say I have a number, it gets sent over here to a number. Then I have another number, it gets sent over here to a number. And then another number gets sent to a number. So this is allowed. This is good because we have, for each car that went in, it went to exactly some new, clean car or whatever it is. This is okay. All right. So this is a function. Here's another picture. Let's say I have car here, car here, car here. Let's say I had this here, here, here. Now, this is where the car analogy kind of breaks down. What we need to look at is, do each of these inputs go to exactly one output? So does that input go to an output? Yes, right? Does the second input go to an output? Yes, right? It goes somewhere, doesn't it? Now it goes to the same place the first input goes, but to be a function, all we need is one in, one out. One in, one out. As long as that happens, it's a function. This one in, one out. This is a function. Okay, this one. Okay, say that goes there. Let's say that goes there, that goes there, that goes there. This would not be a function. And the reason it's not a function is because this one violates the rule, right? This goes to two places and that can't happen to be a function. So one input, one output doesn't work here. So no, right? Not a function. So with that in mind, let's see if we can answer some questions. Determine whether this is a function of X. Now it says here, determine that this is a function of X. What that means is, if we look at this equation, if we imagine that we're going to plug X's in and get Y's to come out through this function, then they want to be sure, is there any way that you can guarantee me that for each input, it will go to exactly one output, right? That's what they want us to do. Is there any way we can just look at that equation and know that that Y is a function, that Y is a function of X? So the way we do this is very simple. All we do is we take the equation, all right, to do this, we solve the equation for Y, okay? solve for y. Now, it's already solved for y, isn't it? The equation's already solved for y. And if we look at this equation, then if I plug in a value of x, just imagine you plug in a value of x, anything you think of, right? 2, 5, -1, -10, 0, any number you plug in, do you agree that you're going to get just a single number to come out? Just one answer will come out. Y'all agree with that? If I plug in x here, let's just plug in a number 3. If I plug in 3, it's 2 times 3 minus 5. Sorry, minus 5. That's 6 minus 5. That equals 1. And see, I got one answer, didn't I? Just one answer. So you can look at it like this. 3 got sent over to 1, right? 3 didn't get sent to 2 places. 3 only got sent to 1 place. And for each number I ever plug in, that's what's going to happen, right? That's what's going to happen. So you would just say here, yes, it is a function. Y is a function of x. Now that might seem a little bit like too easy or weird. So let me show you an example of something that is not. And then you can contrast the two. Same question. Determine whether or not you can look at this as y being a function of x. So I'm going to first solve for y. So I take the equation x squared plus y squared equals 1, and I solve it for y. So to solve it for y, the first thing I have to do is subtract x squared on both sides. So all I did here was subtracted x squared here, subtracted x squared here. And then the very important step, to get y by itself, right now I have y squared, I have to take the square root on both sides, all right? And because I'm doing square root, I have to do plus or minus, right? Anytime you initiate the square root, you have to do a plus or minus. So we're going to get y equals plus or minus the square root of 1 minus x squared. And now when we look at this, the question is, if we plug in an x, am I going to get just one y value? So what do you think? Javier is saying no. Javier, give me an example of a very easy x I could plug in here to verify.
Just 2.
2? Yeah, 2 will give me a major problem though, right? If I do 2 in here, I'm going to get a negative.
Oh,
Just kill it off. Kill this off.
okay, so it'll just be x.
Yeah.
Like what?
Put 0 in there, right? Put 0 in for x. What would happen if you plug in 0 for x here? It would become plus or minus the square root of 1 minus 0 squared, right?
Mm-hmm.
And then that would just give you plus or minus the square root of 1, which is going to give you plus or minus 1, right? Which means you have 2 outputs. This 0 gets taken to 1, and this 0 gets taken to -1. And therefore, it goes to 2 places. And so the answer here is no, it is not a function. Y is not a function of x. Because when you try and solve for y, and then start plugging x values in, you get 2 outputs. So while we're talking about these 2 problems that I just did, let me go back and look at the first one we did, 2x minus 5. I'm going to, if I can bring up my thing here, I'm going to graph this. Y equals 2x minus 5. I hope that everybody knows that y equals 2x minus 5, if you graph it, is a line. Okay, I would hope you know that. And if we look at this line, what we're basically saying is that if you go to any input you want, pick any x value you want, like if I plug in 5, if I go out here and find the point on the line, I'm only going to get one answer. And that doesn't matter what you pick for x. If I pick -2 and I go and find the point, I'm only going to have one output. So for each X, there's one output, doesn't matter where it is. Any X value you have, there's one output and one output only, right? Now, if we try the other equation, the one that didn't work, it was X squared plus Y squared equals 1. I don't know how many of you know this. Hopefully some of you do. That's the equation of a circle of radius 1. So if I kind of zoom in on this, X squared plus Y squared equals 1 is this circle. So if I go to some X value, let's say I pick this X value here, whatever it is, there's actually a point up here and there's a point down here. And then Javier and I were just talking, we let X be 0, and then we got two answers, 1, and then down here we got -1. So this is where this idea of, I know you all have heard of this, the vertical line test comes from, right? If you're looking at the graph of a function, a graph of something, and you want to know if it's a function, then you do this thing called the vertical line test, which says if you draw a vertical line, oh, wrong color. If you draw a vertical line, you don't want that vertical line to ever hit the graph more than one time. If it hits more than one time, right? If any line hits more than once, it's not a function. You all remember that? We're gonna talk more about this next class, but I just want you to see why that's the case. Over here on this line, doesn't matter which lines I draw, any vertical line will hit one time only, right? So it's this idea of two outputs, right? Two outputs are going to make the vertical line test fail. All right. Let's see, how are we doing here? 20 minutes. The next thing we're going to be doing, okay, again, I'm assuming you've seen some function stuff in your past. If you have an equation, let's say you have an equation y equals 2x squared minus 3x. Right here we have an equation. If I were to ask you, is this a function? Okay, is y a function of x here? You would solve it for y. And if we solve this for y, which it is, and start plugging in values of x, we would notice that no matter what we plug in for x, we're only going to get one output. All right. We're only going to get one output. It's not, we don't have a plus or minus anywhere. So we're always going to get one output. So this is a function of x. All right. This right here is a function of x. So anytime we do know it's a function, we say, yes, it is a function. Instead of writing y equals that, what we do is we write f with the parentheses x and then 2x squared minus 3x. This is the notation that we use whenever we have a function. This right here, we read this f of x. That's the way you read that. So anytime you have an equation where y is a function of x, we can replace the y with this notation f of x, and then you know it's a function. Whoever's looking at this will say, oh yeah, okay, I don't even think about it. It's a function, all right? So this example is, if I give you a function, how comfortable are you evaluating the function at different, finding different values of the function? So like for part A, let me move this down. For part A here, it wants us to find f of 3. So can somebody explain in very simple terms what I have to do here to find f of 3?
Is it kind of like, imagine like y being 3 almost?
Not y being 3. See, here we're replacing the x here is being replaced with 3, right? So just rewrite this right here, but replace the x's with 3's, right? Just everywhere you see an x, just plug a 3 in instead. So this will become 2 times 3 squared minus 3 times 3. That's what this notation means. F with the 3 inside means take this function, replace the x's with 3's. And then just do this, algebra. This is just 2 times 9 minus 9. And this is 18 minus 9, which is 9. Questions there? All right, let's go to B. For B, we want f of x plus f of 3. So f of x right here, that's just the original equation, right? That's just the original function. We can't do anything with it because we're plugging x in for x. So it's just what it is. It's 2x squared minus 3x. But then we want to add to that f of 3. But we just saw in part A that f of 3 was 9, right? So we're just going to add 9. And this is our new answer, right? This is what f of x plus f of 3 is. It's the original function adding 9 to it. Part C is 3f of x. So what does this 3 in front of the f of x mean? We're going to take f of x and do what with it? What is the operation between these two?
Multiply the 3 or multiply by
Multiply 3, right? We're going to do 3 times f of x. So that means I'm going to take 3 and multiply it times this function, 2x squared minus 3x. And when we multiply, be careful because you have to distribute, right? If you have more than one term, the 3 has to distribute to each. So this will become 6x squared minus 9x. And we're done. Questions? I'm going to move this down and keep the functions up there so I can see them. Let's do E. E is negative f of x, which means we just need to put a -1 in front of the function. So I'm going to put -1 times the function. That's really what it means. But that just means a -1 needs to distribute through the function. And then when I distribute, I should get -2x squared plus 3x. So it changes the signs of the original function.
Would we have to put equals y, or could we just leave it like that?
Just leave it like that. That's it, because it wants to know, what we're doing is we're saying, hey, you know, what is oh, wait, you know what? Did I skip D? I'm sorry, I skipped D. I just realized I didn't do D. All it's asking is, you know, what happens when we put a negative in front of the function, right? Oh, we get a new function, right? It's that function, but the signs are changed, right? That's what happens. Okay. Let me go back and do D, because D is actually interesting. Okay, for D, what I'm doing here, and be very careful, the difference between D and E is on D, we're replacing the x with -x. So that x right there, that x right there, that x right there, everything in green gets replaced with -x. That's different than putting a negative out in front like we did on E. So this should be f of -x should be 2. Then I'm replacing the x with -x and I'm squaring it, minus 3, and then I'm putting a -x in instead of x. Okay, so that green got replaced with -x, that green one got replaced with -x. And here's where we have to be careful, because this means 2. Now, if I take -x and multiply by -x, right, that's what this means, negative x times -x, that should give me a positive x squared, because they're both negative. So when I multiply them, I'm gonna get positive x squared. So this just becomes x squared. And then this one is a -3 times -x. Negative times negative is positive, so we get positive or plus 3x. This is what f of -x is. Questions on that one? That one gets people.
I actually do have a question, sir.
Yes.
If the 3 is just one solo -x, why? Oh, wait, the signs, right?
Yep, because I'm doing like a -3 times a -x to give me
Okay.
a positive 3x.
All right, perfect. Thank you.
Mhm. All right, let's do F. So for f, I want f of 3x, which means that the thing I'm plugging in is 3x. So everything in green in the function gets replaced with 3x. So I'm going to have 2, and then I'm taking 3x and I'm squaring it, and then minus 3, and then I'm replacing the x with 3x. So everywhere there was a green, I replaced it with 3x. All right, let's see here. Annika, are you there? I don't see Annika. Dominic, I think, has participated today. Caitlin, have we heard from Caitlin today?
I'm here.
How's it going, Caitlin?
It's good.
Good. So on F here, can you tell me what this becomes? How do you feel about this? Square the 3x. So what's 3x times 3x?
9x squared.
Yep, 9x squared. So I'm gonna put 2 times 9x squared. And then Caitlin, right here, when I put the negative 3 times 3x, what would that give me?
Negative 9x.
Yep. And then last thing is just to put the 2 and the 9, multiply them. That gives us our 18x squared minus 9x. There we go. So just be careful there. You have to square the 3x first before you hit anything with the 2. Don't hit it with the 2 first and make that a 6 and then square. That's wrong. Order of operations. Square, then the 2. All right. So next one, G. What happens if we take F and plug in x plus 3? Ooh, that means that everywhere we see an x in the original function, it gets replaced with x plus 3. So I'm going to call on someone here, some unlucky person here, and I want you to tell me what to write, including all the parentheses. And Zachary, you're up.
Okay.
You ready?
Yeah.
Okay, go for it.
So 2 parentheses x plus 3 close parentheses squared
Perfect. Good.
minus 3 parentheses x plus 3 close parentheses.
There we go. Perfect. The parentheses here are absolutely critical because you're squaring everything, right? You're squaring the whole x plus 3. So you have to put the x plus 3 in parentheses. And then you're multiplying 3 times x. So 3 times the entire expression, or I should say minus 3, has to be distributed through. So good job, Zachary. Try and get through everyone here today. Sana, I think you answered earlier, but
I just kind of said like one thing earlier.
yeah. How do you feel about what to do next? Or
Good.
what would you do next?
Or okay, so I would square the x plus 3 first.
Okay, so you're going to take care of this right here.
Yeah.
And just out of curiosity, is that something that you can do in your head, or do you need to write it down on the side?
I kind of have to write it just because
Okay.
I get like confused.
That's fine. That's fine. I'm just curious more than anything else. So you're going to do x plus 3 times x plus 3. And go ahead and do that. Tell me what you get here. Just take me step by step through it. What would you have?
Okay, so you'd get x squared
Okay.
plus 3x plus
Okay.
3x
Mm-hmm.
and then plus 9.
Fine. Okay. And then collect your like terms.
And then you get x squared plus 6x
Mm-hmm.
plus 9.
Perfect. Okay. So that's what x plus 3 squared is. Yes.
Mhm.
Okay. So now let's go back down here. We're going to write 2. And then your answer, right? That you
Yeah.
just got over there.
Mhm.
So when you write that, would this be correct for me to write it like this?
And now you put a parentheses around it.
You have to have the parentheses. And that's because that 2 has to distribute, right? That 2 has to distribute through.
Yeah.
Good, good. All right, I'm trying to get through people now. Very good. Let's see, Javier. I think Javier has played today. Let's see, Alyssa. How you doing, Alyssa?
I'm good.
You look like you get this too. Is that my correct interpretation of your?
Most of it.
Okay. So when we do this, next step would be what? What would you do? We've expanded this and put it here in front of the 2. So what would you?
I would expand the x squared plus 6x plus 9.
With the 2? You want the, you mean put the 2 through?
Yes.
Yes, okay. So you want me to do this? And then, but how about over here, Alyssa? What would this become? I just really wanted you to tell me what this would become.
That one would, you would also distribute the -3 into the parentheses with the 3x, 3 plus x.
So you would get negative, what would you get?
-3x minus 9.
Minus 9, okay, good. And then we'll distribute the 2 through, right? And get 2x squared plus 12x plus 18, but then we still have minus 3x minus 9. Then we collect like terms together. So again, I'm trying to get through people here. Alyssa, thank you. Adeseli, are you there? Let me see Adeseli. Miguel.
Yeah, I'm here.
Yeah, you've participated too, but just tell me, put stuff together there. Tell me what the last line is going to be here.
So it'll be 2x squared plus 9x plus 9.
Plus 9x plus 9. Everyone agree? Good? Yes? Okay, very good. Okay, so that's what happens when you plug in x plus 3. I want everyone to try h on their own right now. Let me see if I have room to move this down. Yeah, I want everyone to try h on their own. And if you get it, I'd like for you to type it into the chat. Well, it might be hard to do in the chat, but if you type in the chat, like, let's just say your answer is like 2x squared, just put a little caret squared like that to tell me x squared. That would mean 2x squared. All right, so try h on your own right now. This will be the last thing we do today. While you're doing that, I'm going to go look at the homework assignment and see what problem you can go up through. I'm gonna let y'all keep working here. On the homework for 3.1, there's only 2 problems that you need to do. All right, but they're both problems like this, where there's like 8 parts to each one. So see how it goes. I'll let you finish this though. We only have 4 minutes, so see how much you can get in 4 minutes. Nobody is, oh, there we go. We got our first answer. Okay. Okay, I put the answer up here and I boxed it. And I tried to show as much work as I could.
That's what I got, but I don't know why when I got to that, I thought that like I had to do something further.
Nope, this is it. Yeah, there's
Same, it's fine.
nothing you can combine together here. We don't have any like terms. So we're gonna end class. Here's what I'll say. This last one we just did, H, is the most important one out of all of these. Because in Calculus 1, we spend like 2 or 3 weeks doing things that involve that. And we'll get more into that next class. So for now, for tonight, just finish the 1.4 homework, right? That's stuff from last time. And then do just these first 2 problems. Then we'll come back on Wednesday and we'll continue through 3.1. Any questions? You're free to go. Thank you for your participation, for having your cameras on. Appreciate that. And if you have any questions about this part H, just hang out and I can answer any questions if you have them. If not, see you on Wednesday.
Thank you.
Bye.
Thank you.
Thank you.
Bye-bye.
Bye.
I don't have any questions on it. I know I sent the wrong answer in, but I realized where I made my mistake.
It's okay. That
Yeah.
was just to get a feel for how long it was taking people to get it done.
Yeah, when I looked, yeah, because I finished it and I was looking at mine and I looked up because I saw you doing it and then I immediately realized what I did wrong. So
Okay, cool.
yeah. Thank you very
Thanks,
much.
Dominic. Have a good one.
Yes, sir. You too.